The first step when designing an artificial intelligence tool is to think about the business problem. What is the goal we want to achieve? For that, it is fundamental to have a clear understanding by the different stakeholders and teams involved, whether they are subject matter experts, business sponsors, computer engineers or other technicians profiles that are going to be involved, data scientists, data analysts, all together must have a clear understanding on what is the current state of the situation, what is the process that we are working on in a business or in an organization, and what are the key purposes, what are the key goals that we want to achieve. Having a clear concept, a context about the business itself or the organization purpose, and understanding where we want to achieve is going to help to define the requirements, to clearly identify the goals and the expected results that we are going to obtain the building of the project of artificial intelligence. These technologies enable a whole world of new use cases, but it's clearly basic that we understand and define with quantifiable and measurable metrics what is the goal that we're going to achieve. The most important part is to keep a good communication process that enables both business stakeholders and engineers and data scientists align in order to identify those KPIs that are going to measure how the initiative is going to be built. For example, if we're going to build a solution for a retail store that is going to predict which products might a customer like in order to show them on their web landing page, we must clearly identify how many customers are we dealing with, what kinds of products are we suitable to show, what are the expected sales increase that we're going to achieve, what are the expected time that the customers are going to spend on the website. Are we going to decrease churn in this scenario? We have to think that all those metrics from these different use cases must be very well defined. And we will dive into more real scenarios within the course, but you can imagine, for example, if we're going to detect anomalies in a log of a machine, industrial machine, that is doing tests, for example, and that machine generates a log, we must quantify, are we going to decrease the maintenance errors or the maintenance cost due to this prediction of possible anomalies on the logs of the machine? Are we going to obtain a better usage and allocation of the machine in our industrial process? So that it's key to first identify what is the key business problem, which are the metrics we want to achieve, and once we know what scenario, it's where we can then start mapping the business problem with the data science model and the data science strategy or the kind of algorithms that we're going to use. For example, if we are going to predict whether an image from an X-ray from a patient might be diagnosed with a type of disease and requires further medical investigations, we're dealing with a classification of images between healthy and unhealthy of the image. But on the other hand, if we are, for example, working with a finance model and we want to predict how much the budget might increase or decrease in the following months based on our historical data, we are dealing with a linear regression prediction, a regression time series forecast problem. So that's where we're going to start thinking about classification, regression, and we come back to supervised machine learning. But don't worry too much about the types of artificial intelligence for the moment. Just keep in mind that it's very important to define exactly with measurable and written achievable objectives what is the business goal or the purpose that we want to achieve by using artificial intelligence. Once we have defined some use cases scenarios or those business cases, the second question we have to keep in mind is, what data do we have? Where is that data? Is it already existing and digitalized? Does it exist in our organization, but it's not digital, it's not accessible, it's in paper? Once we identify the data sources, like for example, the most common are the CRM, which represent customer relationship management software, or software related with how we manage our clients, our customers. We also have the enterprise resource planner systems, which is software that identifies our workers, our employees, the transactions of the company, purchases, salaries, and we of course might have plenty of other systems involved, like laboratory systems, LIMS, or management of human resources systems. And well, depending on the industry, we will have plenty of software applications that are called operational or transactional because it's where the activity of the business happens. It's where the events takes place. If we're talking about e-commerce, the website where the transactions are done, when I can purchase any product, I can look for different services that I'm interested in and eventually apply or input my data to acquire one of those services. That would be also a sales platform. But you can imagine of digital platforms like social media, LinkedIn, Facebook, all those might be included in the business process that we're looking for. And it's where the raw data or the original operational transactional data is generated. Once those sources are identified, we could start thinking about how to extract them or read them for our data science models. Then we have to take a look at the functionality from the functional point of view of that data and assess its quality in terms of defining what it is, what does it represent, what unit is it written, the accuracy, completeness. We have to understand if it has several attributes or characteristics of the data that it's going to be helpful to shape our business problem. When we match the goals that we want to look for, like increase sales, decrease costs, augment a capacity from a certain process, do we have all those concepts from the functional point of view that we need? Do we have, for example, the knowledge to identify if an image of an X-ray is healthy or not? Can we see, like, for example, if we're looking at a solar thermal panel and with a drone images, if that image is working or not, if the solar panel is working or not. So probably we need to have the data qualified and enriched to have the quality enough to be able to be used to train our model. And within that process, normally you need subject experts. Those matter experts normally have been within the industry for several years and are key users of the transactional and operational applications and are going to be key in order to identify the data sources, discuss with the data scientists and the artificial intelligence engineers and developers about what data do they need to achieve the initiative description, the requirements. After that, it is key to also ensure that regulations on data are compliant. We need to take care of the privacy, the personal data. Any data that's flagged as personal is the more risky for incurring in privacy concerns. Names, addresses, personal information about health, about the identity, any personal data must be considered and reviewed by experts on the matter to apply with the regulation on each region and the international norms. These regulations apply also for other data, and we must make sure that we will apply from the computer engineering point of view the required techniques in order to manage the data that we're going to include into our training models. Just to describe a little more about those include decoupling personal information from users in order to make it aseptic and not linked to any personal usage person. Also, we're going to apply the right to delete the information, and we're going to apply a lot of transparency methods in order to understand clearly what data are we using and that the data is not skewed to any particular demographic, for example. And we will deep dive more in more chapters, but there is the concept of unwanted bias that might appear while we are working with artificial intelligence and statistical software. And we will take care that this bias is not skewing the results unwantedly in an unfair manner. For this data collection topic, it's good to know that there are several tools. Of course, the sources have connectors to those applications, the ERP, the CRM, IoT devices, APIs of applications. The data might be structured or non-structured, unstructured or semi-structured. That means a structure, it's in columns and rows, like in a database on an Excel spreadsheet. That means it might become in other formats, like might be XML, JSON, which could be semi-structured. But then we're talking about images, which come in pixels, videos with signals, continuous signals. Of course, that we call unstructured data, but we can also have it as an input, very useful. Some tools like AWS Glue, Azure Data Factory, Snowflake Pipelines, Databricks. There are plenty of applications that will help us to extract, transform, and load the data in a data model useful to generate feature engineering or to feed the data science artificial intelligence model. So we know what is the business problem. We know where to find the data. We take care about regulations and what data we're going to extract and use. We are constantly mapping that with the business problem. And then it's good to know that the data engineers or data scientists always engage in a part in which we transform the data in order to be useful for the data model, the data science model, algorithm, whether it is k-means, isolated forest, any classification, supervised learning, unsupervised learning, artificial neural networks. The data must be prepared, transformed, normalized, in order to generate the features that are going to be the elements where the data science model is going to look for patterns, and it's going to be able then to, based on those patterns, to predict and to achieve the outcomes that we expect from it. So, for example, if we want to apply the churn, everybody knows what is churn. Churn is a process when a customer has engaged with you in a service, but then suddenly you stop the commercial relation with the company. For example, if I have a telecom company for my cell phone and I've been having the service for 1 year, but suddenly I start having bad connection bad users, assistance and support, and I moved to another company. For my original company, I would have committed churn. So if we're talking about churn, as example, you might have a lot of data from me, as a customer, for everyone as a customer. You will have a lot of data about what services, what products was I subscribed with that telecom company. And of course, based on those data, I'm going to extract what we call features, and those features are going to describe my patterns, my behavior. Based on that, another customer that might have similar patterns or similar features, values, it's susceptible of incurring in churn. And that's where we're going to apply marketing retention techniques in order to prevent that customer to leave the company. That's why we must prepare the data that we have exported from the CRM systems, and we're going to transform it. What transformations do we have? Normally, the data science models only like data that it's scale. That means if we're talking, for example, about consumption, if we have very small values and very high values, those are going to cause interferences in the data model. So that's why we're going to apply what we call normalization, and instead of having a range from $10 to $100,000, we're going to normalize all values between 0 and 1, or -1 and 1. But that's something that the data science model likes and is able to work with. Also for text values, for example, I have a column which is called payment method, and I have credit card, American Express, check, transfer, bank transfer, etc. All these text values, we are going to hot encode them and transform them by Boolean values, zeros and ones, and we're going to create those features that are readable by a neural network, for example, or another data science model. So we keep in mind that we have identified the business problem. Second, we know where the data is. We know the data of the process that the business problem happen is extractable. We know the system where it is generated. Then we know that we will have to transform it when we engage in the building of the artificial intelligence model or the training of it. And then when we have the data, we know the business problem, we can think more in detail, although it's something that we're going to do, of course, iteratively. We're going to know what techniques from machine learning, from deep learning, from reinforcement learning, from the whole set of domain knowledge of artificial intelligence is suitable for resolving that business problem. Of course, we will have the help of the senior data scientist, but in this course we will also understand what's the difference between a classification problem and other techniques that we're going to apply. When we're going to choose the artificial intelligence and machine learning techniques, it's important to know that we have prediction, we can classify images, we can identify text, we can generate text, and well, all the set of AI and machine learning use cases. Then we are going to use that model. So for that we have the models. It's something good to understand, are normally already pre-built by those big universities and big companies like Facebook, AWS, Azure, Mistral, Anthropomorphic, plenty of them that have built for the community Meta, all those models, and they have libraries that we can use. We have Google also, of course, that has participated a lot, and the community can use them. So we have normally a lot of services available to use and to learn. especially. It may sound familiar to you that a lot of them are written in Python. They can use Spark machines or Elastic MapReduce. And of course, we have scikit-learn, Keras, PyTorch, TensorFlow. It's just one of the most famous libraries and frameworks where we can select the different types of artificial intelligence and machine learning techniques. We will see that further in the course. For the moment, it's important to keep in mind that next phase after identifying the business problem, the data, and knowing a bit what type of machine learning problem we're going to use, we're going to develop the model and train it with the data. We will use several techniques like train, test, split, cross-validation, parameters tuning. We will deep dive them a bit more in detail, but that's the moment where the data scientist, the artificial intelligence scientist, starts its work, and that's where we start working with the model. So we choose the algorithms, as to know, regression, decision trees, neural networks. We train and validate the data, and we are going to use platforms that are going to help us, once we have trained the data into the model, to determine whether the results are accurate enough, the probability of the predictions are fine enough, and then we're going to use those tools to deploy that model and make the model accessible by all users. So what do we have in the end? We have the steps of building the model, having chosen the right algorithm, evaluating that model, and then deploying the model, which means to enable an application that is going to call our model and infer new data in order to obtain a result. For example, in a facial recognition software, is this image myself? It isn't. Does this person wear a helmet? No, there's not a helmet on that image. What percentage of accuracy do I have that this image does not have a helmet and it's, for example, someone's hair that looks like a helmet? That type of evaluation is what the model is going to do to give us, and that we're going to evaluate before deploying and make it accessible for everyone. So once we have trained the model and we're going to assess the performance, there are some concepts that it's important to understand. First, we will have the technical measure. This is something that, as I just explained, the data science model and the tools we are going to use, Azure Machine Learning Studio, SageMaker, Vertex AI, several tools in the market that help us to train the model, input the data, test the data, and then watch the measure of the technical performance. So for classification problems, in which we have labeled some images and we want to get for a new image, for example, is it that type of object or not? Or where we have, for example, a set of words and we want to identify from this list of words which of them refer to a happy comment and which of them refer to an angry comment, for example, for claims or for customer support. We will have a bunch of text, and the accuracy and the precision, the recall, the F1 score, and the area under the curve are different ways of evaluating whether the final predictions have had some errors on the test data. We will see it more in detail. Then for regression, which is where we want to predict a numerical value, for example, a purchasing revenue in the next years, or a stock market value of a company in the next months, we use the root mean square error, the R-squared coefficient of determination, and all other statistical measures that, by knowing which ranges and which thresholds they have, the data scientists are able to know if the training and the model applied with the data we trained the model and the tests we did are good enough to be able to pass it to production or not. After that, the second step in the artificial intelligence life cycle is to move to map the technical result metric to the business interpretation of that and translate it to the business value that that result might have. So, for example, if we have an application to estimate and predict the churn of our customers, and we know that, for example, for 10 customers that are new and we infer them to our model, based on the data, we get, for example, 5 that will not churn, 5 that will churn, but then when we compare with reality, we realize that in the end, 8 did not churn, 2 did churn, but one of the ones that churned is not one of the ones that we predicted that was going to churn. So that type of analysis is what we can evaluate by training the model with a lot of data. And that process of monitoring and evaluating and assessing the model performance, it's key, and it's an ongoing iterative process that will help the business value to be maintained all along the life cycle of the application. Once we also evaluate the model, we have to consider that the errors might have several root causes. So we will apply a system to identify those errors. And those errors might be because of concept shifts. The concepts of the data that we were wanted to use to explain the results that we are going to predict might have shifted, or we might have problems with the source data. It might be skewed. We might have a lot of data from one particular type, so other types of scenarios are not well represented, for example. Or when training the model, we might find overfitting or underfitting, which might be that the model works very well for some data that we have trained on, but when we include new data, the model does not fit so well. Or we might be underfitted, which is the opposite, where the model doesn't predict very well. Once we have trained the model, there's a continuous process of evaluating the result. And it is key in this area to let the data scientist understand the technical metrics and be also have someone in your team that is able to translate those technical matters to a business scenario. Like the one we predicted from churn, if we're going to detect churn for users that did not churn, it's not so important because, okay, we can lose a bit of effort when we are applying marketing campaigns, retention campaigns for customers that are not going to churn. We lose a bit of effort, but it's much worse and much risky if our model does not detect a customer that is going to churn and did churn, and our model missed it. So that would be a false negative and a false positive in the first case. Deploying just means to get that code of our model with the trained data, with the parameters and the configuration that the algorithm has learned, and we publish that code as an application. And that application is ready to get data from other systems and to generate a result, a classification or a prediction on those new data. This is a loop in which once the first iteration, and we have that model, we have to ensure that our team is ready to monitor the deployment model, and eventually also in the end, depending on the business problem, we will need to retrain the model with new data and evaluate again to monitor the accuracy and that the business problem is being tackled in a right manner and results are being obtained as expected in the initial use case. For that, it's key to collect feedback from users that have been applying our model and to see that the data generated by our model is also inserted as a data source for newer features engineering, features analysis, and retraining of the model. There are concepts that are very interesting to discuss here. Is the concept of real-time and batch inference. Real-time means when we are retraining the model, each time new data appears, which of course is more costly. And then we have batch inference, which is when we apply the deployment of the code and we apply the new data only at night. For example, I want to predict the churn for all these new customers. Just do it once and tomorrow you will have the result. Or in real time will be a new customer logs into my web platform and by its activity, what website has it discovered, where did he navigate or she, then this information is quickly inferred into my deployment system and it might imply an output of risk of churn or not, and then another application might send a notification to a customer agent. Keep in mind that it's key to begin with the business understanding to start any AI initiative. Establishing the context, having good communications with the teams, then we will have to engage in maintaining a good collaboration and engagement within those business analysts and business users and the data scientists and technical developers in order to identify data sources and build and train the data model. Then we will have to document every decision and document every assumption in order to have transparency for evaluating and monitoring the model. And of course, we will have to measure and compare the business impact, the business objective, with the outputs of and result of the applied model. So remember, this whole life cycle implies all these 7 layers. During this course, in the next chapter, we will see real scenarios within all of these steps for you to be able to identify what are the key actions to apply in several business scenarios and different artificial intelligence models. So thanks a lot and see you in chapter 3.